What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at rounding decimals, and this is a really important skill throughout your mathematical career. It's going to pop up again and again in heaps of tests going forward because every single test is going to ask you to round something to 2 decimal places or to the nearest whole number. And if you can't do this correctly, you might lose a mark in every single test going forward. So definitely stick around for this one because I guarantee it's going to help you out in the future. So the key thing about rounding a decimal is that it's really just a guess of what the number is. If you throw a number into your calculator and you get heaps and heaps of decimal points, instead of writing all those down, we just want to cut it off at a certain point. The question will tell you where. And we're just going to say, hey, that number's good enough to represent all those decimal points that come after it. The easiest way to think about it is using whole numbers or estimating the size of a group of people and rounding it to the nearest whole number. From there, we are going to get into our decimals after the dot point. But I think if we see some examples where we're using whole numbers first, it's going to make a little bit more sense. So for example, if you had a class of 28 people in the class and you were trying to explain to your mum or dad how many kids in the class there were, instead of saying 28, you might say, oh, there's 30 kids in the class. You definitely wouldn't say there's 20. 30 is a much better estimation of how many people there are in that classroom. So what we say is that we are rounding 28 up to 30. Again, if we were trying to look at how many people went to a footy match, if you had 1,230 people in the ground and the local paper was going to say how many people were there, they would probably say 1,200, not 1,300, because 1,200 is a better estimation of that group. In this same example, if you wanted it to the nearest 1,000, you would say that there were 1,000 people there, not 2,000 people there. So it's really just about communicating what is a closer number, what is a good estimate for the total number of people there. So the same thing, exactly the same thing happens when we're talking about decimal points. Really, we're just asking, well, what's closer? What's a better guess? What would say to someone else the most accurate information that's not exact to every single decimal point that could be written? For example, if you were doing high jump and you jumped 2.8 meters and I said, oh, how far did you jump? It would be way more correct for you to say, oh, I jumped 3 meters than I jumped 2 meters. So that makes sense. You would round up in this situation because 2.8 is way closer to 3 than to 2. So 3 meters tells me more information because it's closer to that number instead of rounding all the way down to 2 because you did way more than that. You jumped an extra 80 centimeters and you're only 20 away from that 3 meters at the end. So if we just looked at this on a number line, we've got in between 2 and 3 meters, the exact same example. You would say that anything from 2 all the way up to 2.49, we've jumped 2 meters. We're closer to 2 than we are to 3. And then on the other side, anything from 2.51 all the way up to 3, we would say we've jumped 3 meters because we're closer to the 3 meter side. The one thing that's important to note is what happens if I jump exactly 2.5 meters? I'm smack bang in the middle. So how far did I jump if I need to say it in a whole meter? The rule that we use is that we always round up. It's kind of like we're exaggerating, right? If you're at 2.5, hey, just say 3, you did a good job. So anytime that the last decimal is a 5 and then you are asked to round, we are going up. So 25 becomes 30. 2.5 becomes 3 and 0.25 becomes 0.3. In all of these examples, we've gone up on the decimal that is before the 5. So we get rid of the last number and round that other one up 1. So when you see these in a test, there's probably going to be 3 that you will see more commonly than anything else. The first one is, hey, can you please round this to a whole number? This usually happens in worded problems. We might say, oh, how tall is that person to the nearest centimeter? How hot is it to the nearest degree? Something like this where we have a specific number, a whole number, and we just want that in order to communicate the information. And again, because it's a whole number, we don't want to have a decimal in our answer. So for this first example, we've got 322.4 meters, and we want this rounded to the nearest whole number. The only thing we need to look at is the first decimal after the dot point. So that's 4. 4 is less than 5. So that means we're closer to 322 than we are to 323. So that means we are rounding down for this question. So my answer is just 322 meters. Done. So for this one, if it was 25.6 degrees and I wanted it to the closest degree, 6 is the number that's important. Because that's bigger than 5, I've got to round up, and that makes this 26 degrees. That's the closest degree to the actual temperature. The next type of question is you might be asked to find to 1 decimal place, and this means we want one number after the dot point. The really important thing here is that the second number is the most important one. That's where we're going to find all our information. This is the hundredths number, and once we've found that, that's where our work's going to start. For this first example, I've got 3.77. The important number is the second decimal place. If this is bigger than 5, I round up. 7's obviously bigger than 5, so my answer becomes 3.8 because this one has rounded up. Happy days, we're done. The next one has way more decimals after that dot point, but the only one that matters again is that second one. That 3 there is our important information. Because 3 is less than 5, we don't round up, we round down for this example. So it just stays as 42.6, and that is our final answer. Nothing changes because we're rounding down. This next one, we've got 0.081111. Again, the second decimal, the one after what we want to round to is the important one. 8 is bigger than 5, so that means we are rounding up. Because that goes up, the 0 in front of the 8 turns into a 1. So my answer is 0.1. Probably the most common one that you will see is round to 2 decimal places. This is pretty standard in a maths test. So again, because we're rounding to 2 decimal places, the important number to look at is the third decimal place, right? The one after the thing we've been told to look for. Again, once you've highlighted that, once you know in your mind what it is, if it's 5 or above, we round it up. And if it's less than 5, we round down. So this one, 0.827, the 7 is the important number there, the third one. And because 7's bigger than 5, we're going up. This is closer to 0.83 than it is 82. So that means my final answer is 0.83. The next one again has heaps more decimals after the dot point, but we are only interested in the third one. And this one is the 5. Remember that the 5 means go up. Even though it's halfway, it means go up. So that means that we've got to change the number beforehand. This becomes 143.27, and that is my final answer because that 5 has said, hey, let's exaggerate, we're going to round up. The last one here is 19.374. Again, that 4 is the important number. 4 is less than 5, so we are rounding down, keeping the 2 decimals the same. So my answer for this one is just 19.37. So the checklist that I want you to go through when you are answering these questions is underline the number that is important first. If it says 2 decimal places, the third one is the most important. If it says 1 decimal place, the second one is the most important. Being able to identify the important decimal place straight away is the key skill here. Making sure you can do that is the number 1 priority. From there, if it's a number that's 0, 1, 2, 3, or 4, one of those lower numbers, we just keep everything the same. We can just lop off all the decimal points that we see because we are rounding down. It stays the exact same. So if I had something like 0.12344, whatever, if I said round this to 2 decimal places, I'm looking at that 3. That's the important one. Because it's lower than 4, right? It's in the bottom half of our numbers, 1 to 9. All we have to do is just lop off everything else that we don't need, and my answer is 0.12. Nothing else changes in front of it, because I just have to cut away those numbers to round down. And then if it's the other case, one of the higher numbers, 5 to 9, all you've got to do here is again, lop everything off. But because we are getting rid of everything and saying, hey, this goes up, the number before the last decimal that we want has to increase by 1. So in this example here, again, to 2 decimal places, that 0.129, 9's the important number, bigger than 5, obviously. When we get rid of that, it means that we have to jump up to 0.13 because 1.3 is way closer to our actual number than 1.2 was. So this is something that you do need to practice if you're not 100% on top of it, but just identifying the number after the decimal that you need is really, really important. That's our first step. Once you get on top of that, starting to just think about, hey, what's closer, the one down or the one up, will really help you start to get these things correct. Thanks so much for watching this one. Hit that subscribe button down below, and I'll see you later.